I'm just going to do a brief overview here on the initiative. So let's begin by addressing the motivation behind oneAPI. The high demand for acceleration in high-performance computing and AI requires multiple architectures, so CPU, GPUs, FPGAs, and other accelerators, XPUs. And many data-intensive workloads perform best when they are deployed across a mix of those. And in fact, there's a study that says that nearly 48% of the developers are now targeting heterogeneous systems that use at least more than one type of processor. However, programming for different architectures often means using unique languages, tools, and libraries. And this increases a lot of the complexity and limits the code we use, making it challenging to fully leverage the multi-architecture systems and maintain code efficiently. So developers are frequently confined to vendor-specific ecosystems, which can restrict somehow the innovation and increase the development time. So oneAPI, in a way, provides developers the freedom to choose their hardware by offering a direct programming model that targets multiple devices. And the powerful oneAPI libraries accelerate functions like math operations, neural networks, ensuring high performance, and especially Cycle has proven performance portability across devices from various vendors, including Intel, AMD, and NVIDIA. And this means developers don't have to write different code for each platform, boosting productivity and reducing the time to market. So yeah, this commitment to focus on promoting the open programming that frees developers from constraints of proprietary software. By embracing the oneAPI programming model, we join forces with others to drive a vendor-neutral software ecosystem for accelerators. And I think this is a pretty big topic, a pretty big point for me. It is a flag that I like to raise. So this collective effort is a proof that broader industry seeks an open alternative to proprietary platforms like CUDA. For example, there is a growing movement to ensure high-performance application code not locked to specific hardware, such as NVIDIA GPUs, for example. So yeah, so here we can discuss what I've just mentioned at Cycle and the direct programming language of oneAPI Cycle. It's a object-oriented parallel programming, and it's designed to run on multiple compute devices, as I've mentioned it. And some developers are often concerned about performance loss when switching. However, benchmarks show here that migrating workloads achieve comparable and sometimes higher performance on NVIDIA devices. And those tests here that we can see on the graph are on a NVIDIA A100, and the system across 10 workloads demonstrate Cycle's high performance. So yeah, additionally, Cycle is effective on architectures like Intel, AMD, RISC-V, ARM, PowerVR, and etc. Also, tools like Cyclematic simplify the porting code from CUDA to Cycle, so enhancing the development efficiency on this migration. So yeah, the software tools powered by oneAPI provide a flexible software stack here. So the oneAPI base toolkit, especially that we see here on the bottom, includes C++ with Cycle, some compilers, libraries, frameworks, and it works. I think it's pretty popular because it also works on some libraries, important libraries like TensorFlow and PyTorch. And yeah, so on today's data-centric workloads, they demand a really diverse type of hardware. So this introduces the complexity, and the space toolkit simplifies this, offering some standards. So it provides all the essentials to build and deploy high-performance applications. The toolkit includes advanced compilers, libraries, and also the tools for analysis. So one really cool feature is one tool is the vTune profiler, which analyzes some hotspots to optimize code efficiency. And also we have like advisor that helps you determine the optimal mix of computing resources offering like advice on threading, multi-core usage, and GPU offloading to maximize the performance, which are really cool tools that can be used in this scenario.